Welcome to TGL Physics. Today we are going to study about equations of motion. There are the three equations of motion. The first one is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. And the third one is V square is equal to U square plus 2AS. What is the meaning of this? V is nothing but final velocity, U is initial velocity, A is called acceleration, and T is time. So how to derive this graphically? So let us consider, here is a car. Car is at rest position near the tree. Whenever it starts, it has an initial velocity. Let us say the initial velocity U is 5 meter per second. Now I am going to consider at position A. Position A to B, there is an uniform velocity. The car moves after the 1 second, 10 meter per second. Then the 2 seconds, it is going to be a 15 meters per second. Then at 3 seconds, it is going to be 20 meters per second. Then it reaches to the final velocity, let us call it as a V, is 20 meter per second. Now I want to mention this particular thing using a what here? VT graph. So you already know that what is the meaning of VT graph? Velocity time graph. So you just see a car is at initial position, that is O, here is 0, or we can say 0 is here. Then it moves with the 5 meter per second, and it is A. You see here is A. So therefore from A, after 1 second, it is going to be a 10 meter per second. Then after 2 seconds, it is reached the 15 meters per second. After 3, so there is a 20 meters per second. This is a representation of VT graph. This particular motion I am representing with the water graph. You already know that. First let us prove that V is equal to U plus AT. So here is the first equation. Let us prove this one. You already know that the meaning of acceleration. What is the meaning of acceleration? It's a change in velocity divided by what is that? Time taken. So what is the change in velocity? A change in velocity is nothing but the final velocity minus of what is that? Initial velocity. The final velocity minus of what is that? Initial velocity. Therefore, we can say final velocity minus of initial velocity divided by change in time, or we can call it as a time. Graphically, let us see. What is A? A is equal to. What is the final velocity here? The final velocity is B to what here? D. Is the final velocity. B to BD. Minus of initial velocity. Initial velocity is the, here is A to what is that? Is an initial velocity. What is the time taken for this? Time interval is this much. That is called D, or we can say OD. Therefore, A is equal to, what is BD here? The B to D is the final velocity. Let us call it as a B. AO is nothing but what here? Initial velocity is U divided by OD is T. Therefore, so change the subject of this equation. V minus U is equal to what here? A into T, AT. So therefore, the final equation what we are getting is V is equal to U plus AT. This is termed as a what here? The first equation of motion. Welcome to TGL Physics. So yesterday we have already discussed about there are three equations of motion, and also we have already proved that V is equal to U plus AT. Now let us pass on to the another equation, that is S is equal to UT plus half AT square. Now what is the meaning of the displacement? Displacement we can able to find out with the help of what here? VT graph. So here is a graph AB. Below this, area below this graph is always gives about a displacement. Therefore, displacement is nothing but area of the trapezium. You please see where is the trapezium. You please see this one O A B D. Please once again you please see O A B D. It looks like a what? Trapezium. Just I will put this one. Okay. You see this particular area. It looks like a what? A trapezium. Now, OD is the height of the trapezium. OA and also the BD are the what here? Parallel sides. Now, displacement is given by S. S is equal to area of the trapezium OABD. OABD. Now, what is the area of the trapezium? You already know that half into the height into parallel sides. A plus B. This is the formula to find out the what here? Area of trapezium. Now, S is equal to half. What is the height of the trapezium? Height of the trapezium is O to D is the height of the trapezium, or we can say into this one is C. Okay. So therefore, H, that is OD. A plus B. What is the A here? A is OA. O, A is nothing but a what here? A. That is one side. Another parallel to this one here. So that is nothing but a what here? BD. B to D. Now you already know that. What is the meaning of OD? OD is nothing but what here? The time taken for traveling. So this is OD. This is nothing but a what here? Time taken. What is OA? The OA is nothing but a what here? U. It is nothing but an initial velocity. So we have already there initial velocity is U. Plus of. What is the BD? The BD is nothing but a what here? The final velocity. So we already know that from the equation, first equation, V is equal to what is that? U plus 80. So please substitute here. The V is equal to U plus 80. Now what you will get? S is equal to half into T. U is as it is. For V, we require to substitute U plus 80. U plus 80. Now the remaining part is a simplification. S is equal to half into T. U plus U is nothing but what here? 2U plus of 80. Next one is S is equal to half into T, 2U. 2 and 2 get what here? Cancels. Plus half 80 square. Now the final equation what you get is S is equal to UT plus of 80 square. This is called the second equation. We can solve by what method? The graphical. Welcome to TGL Physics. So, yesterday we have already discussed about the two equations of motions. That is termed as a what here? The V is equal to U plus 18. Another one is called S is equal to UT plus half 18 square. Now let us pass on to the another equations of motion. That is called V square is equal to U square plus 2AS. By using this particular graph, how you will going to prove this one? Okay. Now you already know that in the second equations we have already proved this one. S is equal to UT plus half 80 square. In this, you just see this particular equation. So here we have S is equal to half into T, U plus V we got. So this is the same as what the displacement is equal to area of what here? The trapezium, that is OABD. So let us consider this particular equation in the third equation. So we refer to prove V square is equal to U square plus 2AS. Now let us consider this equation, half into T, U plus V. I have taken this particular equation. We know that V is equal to U plus 18 from first equation. So here we have already proved. Okay, this one. So I have taken this particular equation, the V is equal to U plus 18. So I want the time taken for this. What is the time taken? T is equal to V minus of U divided by what is that? A. Okay, just understand this one. T, here I have it, is equal to V minus of U divided by what is that? A. Just to substitute this particular equation here. Now what you will get? S is equal to half. What is the meaning of t here? V minus of u divided by what is that? A into what is that? U plus V. So this one, V minus U, V plus U. Please observe this. This is in the form of what here? A plus B into what is that? A minus B. A plus B into A minus B is nothing but a what? A square minus of what is that? B square. In the same method or in the same way. So we can able to write this one as V square minus of what is that? U square. Divided by what is that? 2U. Now, V square minus U square is equal to 2A into what is that? S. So what we will get a final equation is V square is equal to U square plus 2AS. So this is the third equation of motion. So with the help of this graph, so VT graph, that is velocity time graph, we can able to prove all of these three equations of motion. That is for first one is V is equal to U plus AT, S is equal to UT plus cos AT square, V square is equal to U square plus 2US. So you already know that V is the final velocity, U is an initial velocity, A is an acceleration, T is considered as what here? Time. With the help of these three equations, we can able to solve many number of problems. Okay. So the problem part or numerical part we will do in the next class. Thank you for watching this.